R double dot. By using this FBD diagram, we will find that the forces of Fn, F, and the Fw. So we have our sign convention is for the summation of Fr is positive. So Fr is equal to MA, right? MAR. Okay? So along our radial axis here, we will find our components of Fn and the components of our Fw, right? Because if we will extend it here, our Fw has also components along here, right? So we will find the Fn and the Fw components. Kanya siya kapalyo diri exactly. Muna siya ang niya mga angles. Kanya siya po diri ng part. Kanya siya, ano na siya. So, kanya siya is 30 degrees, right? Kanya siya is 30 degrees. And kanya siya is 60, right? If this is 30, and if this is 30, here is also 60. So, using the summation of all forces along the radial components, we have our Fn is going down. So, it's opposite, right? Opposite yung direction. So, we have now negative Fn. This is cosine 30. Cosine 30. Then, ang ato pong Fw, yung component is opposite yapon sa ato ang convention nga pasaka, di ba? So, we have minus Fw cosine 60 degrees. Because in this angle, we have 60 degrees. So, it's equal to M, and our acceleration is R double dot minus R theta. So, our Fw, so negative Fn cosine 30. And our Fw is mass times weight, mass times the gravitational force. So, we have 1 kilogram times 9.8 meters per second squared times cosine 60 equals to, also our M has a value of 1 kilogram. So 1 is equal to, and then our R double dot is 8.66 meters per second squared minus our value of R is 0.577 meters, and our theta double dot is 3 rad per second squared. So, solving for Fn, the final value of Fn is negative 9.66 Newton, or 9.66 Newton going down. So, it is correct that our convention is like this. So, next is for our transverse axis, we have our convention is going up. So, summation of F theta is equal to M A theta. Right? So, diri here in our FBD diagram, along theta, along our radial transverse component, we have F, right? F. And also, here, there is also a component along here. Now, next is our transverse axis. Our positive convention here is going up, right? So, summation of all forces along our theta. So this is F. Our F, it has no components because it is along our transverse axis. So along our transverse axis, our there. Right? Going there. This is our weight conversion. And in our normal force conversion here, it's like this, right? This is our normal force conversion. So, next is, solving this equation, this is 30 degrees. 60. If this is 60, therefore this is 30. Okay. So, following this, using this component, summation of all forces equal to NA theta. So, we have positive F, right? Negative FW, sine 30. And also, we have negative Fn sine 60. Fn sine 60. And our mass and the acceleration is just r double dot plus 2r dot theta dot. Okay? So our essentially here this is 0, right? Because our theta dot is now 0. So our F, it has the value of, where our FW is just 1 kilogram, 1 times 9.8 meters per second squared times sine 30 minus our Fn now is minus, because minus now is negative, so we will use this conversion now. However, it could be plus if we will use just the negative 9.66. So 9.66 sine 60 is equal to m times 2 times 3 times 2 times our r dot is 1 meters per second, 1 times our theta dot, which is 3 rad per second. So now we have our F as a value of 19.3 Newton. So